I'm a professor at the Hausdorff Center for Mathematics within the University of Bonn and at Max Planck Institute for Mathematics. I think the math program in Bonn is really good. We really have many top mathematicians here in Bonn. We have the only German Fields medalist, Gerd Faltings. When I was a student, I always went to his lectures and never understood anything. But I must say that looking back at this, I learned so much from these lectures. Generally, Bonn is a nice and green city, and it's not so large, so you can actually get anywhere by bike. So that's really convenient. I actually like the smaller towns. So I mean, there's still all the cultural things and so on that you have them here in Bonn. It's really exciting to work with students. I think it's really fruitful for both sides. So for example, sometimes I give my students problems that arise in my own research, and then they come up with new ways to attack those questions, and this sometimes sparks new directions for my own research. With a group of postdocs and PhD students, we always go to lunch, and this is great because on the one hand you can share your enthusiasm for what you're just learned, or you can ask the stupid question that was just running through your head before you went to lunch, and that surely somebody can answer. I'm working in arithmetic geometry, and specifically a lot of my research is in periodic geometry, where the notion of perfectoid spaces has built a new bridge between arithmetic and geometry. Using this notion, I've been able to prove some new results in periodic Hodge theory, and maybe my most famous result is the existence of Galois representations attached to torsion classes in the cohomology of hyperbolic 3 manifolds, or more general locally symmetric spaces. The key issue for me is finding the right definitions, finding the right notions that really capture the essence of some mathematical phenomena. I often have some vague vision of what I want to understand, but I'm often missing the words to really say that. But then sometimes I read some other paper and there is this definition, and suddenly it clicks, and suddenly I can say what I always wanted to say. There's always an infinite number of problems to be solved in mathematics. I mean, whenever you solve one, there are 10 more coming. Mathematics is a hugely vast field, and every one of us knows only his small chunk of it. But within those small chunks that I know, there's so many open problems. That's good.